Today, we're going to learn how to create our own queue using the wrapping array implementation. Hello, I'm James Helfrich. There are many ways to implement the queue. The way the standard template library does it is with a container adapter. However, a simpler way to do that is with a wrapping array. This video will demonstrate how the wrapping array implementation works. We have four implementation options for the queue: a fixed array, an array of a fixed size; a list where the underlying data structure is a standard template library's list; a deck, or we can let the client specify which container we're going to have as the underlying data structure. This video will talk about the fixed array implementation. To demonstrate some of the challenges of the array implementation, let's first take a look at the stack. Now, when I create a stack of 8 elements, if I say push, I go in slot 0, push goes in slot 1, pop removes slot 1, push, pop, push, pop. Notice how I keep reusing slot 1 again and again. With a queue, things are different. Once again, I'm going to create a queue of 8 elements. When I say push, it goes in slot 0, push goes in slot 1. When I say pop, I remove slot 0, and then push goes in slot 2, pop, push goes in slot 3 and 4. Now, if we're not careful, we will require an array of n slots to handle a queue that performs n pushes. To avoid this, we need to reuse some of those slots more than once, and this is called the wrapping array implementation. So consider a 4-element array. It's easy to imagine the indices go off in both directions infinitely. 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Now, if I'm at index 2, if I increment by 1, I'll be index 3. If I'm at index 3 and increment by 1, then I will not go to index 4 because there is none. I'll go back to index 0. So the formula is index mod num capacity. To see how this works, take a look at this queue and a queue of characters. And I'm going to start by having a queue of 4 characters. But I'm also going to show the wrapping array where my indices continue on and on and on. So if I say push A, that's going to go in slot 0. So I say push B will go in slot 1. I'm going to pop slot 0, push into slot 2, pop, push in slot 3, pop. Now, when I say push E, it's going to go in one slot after 3, which is 0. When I say pop, and I say push. Now, notice how the bottom one kept on going like it did before. It kept on growing and growing and growing. But the thing is, I'm reusing my indexes 1, 2, 3, 1, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. There's one more level of complications. How do we keep track of the head and the tail of the queue? Remember, with a stack, my head was always slot 0, my tail was the number of elements, but with a queue, things are different. One thing I can do is I can keep track of the head and tail. So here I have a 2-element queue. The head's in slot 2 and the tail's in slot 3. Here I have a 1 element where the head and tail are on the same slot, slot 0. But how do I represent when I have 0 elements? Well, I'm going to have my head at slot 0 and my tail is at slot -1, which is just 3. The problem is there is really no distinction between 0 elements and 4 elements. In other words, an empty queue and a full queue are indistinguishable in this scenario. So I really have a couple bad options: keep an extra variable around or burn one item in my array or something like that. And either way, none of them are satisfactory. So let's come up with a different answer. Now I'm going to have 2 variables called numPush and numPop. And I will compute these. I will compute the index of head and tail as I go. So tail is numPush -1 mod num capacity, and head is numPop mod num capacity. To demonstrate how this works, here I have a queue of 6 characters, okay? So remember, I'm going to remind myself of my head and my tail here. So I'm going to say, give me 6 characters, so that's going to be 6 characters. Head is slot 0, and tail is -1, or slot 5. So numPush is 0, numPop is 0. So therefore, my head is 0 and my tail is -1. Now I'm going to push Q. So Q will go into slot 0. And now numPush is 1 and numPop is 0. I pushed exactly once. And so my head is going to be numPop, which is 0 mod num capacity, which remains 0. And my tail would be numPush, which is 1 minus 1, which is 0 mod num capacity. So my head and my tail are both 0, so it's what I expect. Now let's push W here. So that's going to go on to the end there. And now my num push is 2. My num pop still is 0. I haven't popped yet. And my head remains at slot 0. But my tail is now slot 1. Why is that? Because my tail is num push, which is 2. 2 minus 1 is 1. 1 mod num capacity is going to be 1. Now I'm going to push E. And then once again, my num push is going to increment by 1, and my tail is going to increment by 1 as well. And then push R, and my num push is going to increase by 1, and my tail is going to increase by 1. And then push T. And then once again, my num push increases by 1, and my num tail increases by 1. And let's do some math and make sure this is right. I have pushed 5 times, so num push equals 5. I've never popped, so that remains 0. My head is num pop, which is 0, mod num capacity, which is 0, so that is correct. And my tail is num push, there's 5 of them, minus 1 makes 4. 4 mod num capacity, which is 6, is still 4. Now I'm going to pop 1, so num pop equals 1. And now 1 mod num capacity is 1, so therefore my head is slot 1. And notice how num push has not changed, and so tail has not changed. And if I pop again, then my head is going to increase by 1. Num pop is now 2. I head is now 2. Okay, let's look at a more complicated example. Here I have a queue of integers, and how big is my underlying array? 2. Okay, I remind myself of my formula here because this is really going to come in handy. So first of all, I'm going to create my empty queue with 2 empty slots. Num push is 0, num pop is 0, I head is 0, and I tail is -1. Remind ourselves, why is I tail -1? 0 is my num push. 0 minus 1 is -1. Mod num capacity is -1, which is the same thing as 1. So now I'll push on 19. So now 19 goes in slot 0, num push is now 1, and I tail is 0. I'm going to push on 28. And now num push is 2, I head is 0, I tail is 1. We're not in a wrapping state. Everything makes sense. I'm not nervous. What happens when I pop? Then num pop plus plus, I get rid of slot 0. I head is now 1, I tail is now 1. There's exactly 1 element in my queue. Now I'm going to push 31. Where is it going to go? Well, it must go in slot 0, and let's find out why. Now num push equals 3, and now let's compute I tail. 3 minus 1 is 2. 2 mod num capacity, which is 2, is 0. And my head is in slot 1. And why? Because I have 1 pop so far. 1 mod num capacity, which is 2, is still 1. I'm going to pop, and I'm going to pop my head. And now num pop equals 2. And 2 mod num capacity is 0, so I head is 0, and tail has not changed. I have exactly 1 element in my queue. The head and the tail are both slot 0. That makes sense. And now when I push on 49, 49 is going to go in slot 1. And now num push equals 4. And this verify I have pushed 4 times, 19, 28, 31, and 49. And I've popped exactly twice. So now my I head is 0 and my I tail is 1. This is example 12.2 and 12.4 in the C++ data structures textbook.